AI agent development and runtime systems. The frustration with existing AI orchestration frameworks has reached a breaking point for some developers. A new open-source project called Cogitator emerged from what its creator describes as months of fighting LangChain's 150-plus dependencies and weekly breaking changes, offering a self-hosted runtime for orchestrating AI agents and LLM swarms written in TypeScript rather than the Python that dominates AI infrastructure. Cogitator aims to provide a production-ready alternative with approximately 20 dependencies, featuring a universal LLM interface supporting Ollama, vLLM, OpenAI, Anthropic, and Google through a single API. The framework includes 6 multi-agent swarm strategies: hierarchical, consensus, auction, pipeline, and others, alongside a DAG-based workflow engine with retry, compensation, and human-in-the-loop capabilities. Sandboxed execution through Docker or WASM isolation keeps agent operations off the host system, while production memory combines Redis for speed with Postgres and pgvector for semantic search. An OpenAI-compatible API allows it to function as a drop-in replacement for the Assistance API. The Reddit community response was predictably skeptical. One commenter noted the irony of solving Python's dependency problem by requiring Docker, Postgres, Redis, and Node.js with its own dependency ecosystem. The developer countered that these infrastructure components are optional runtime choices. SQLite works out of the box, and that the actual package.json doesn't contain thousands of transitive dependencies. The point about Python still being needed for vLLM was addressed by noting that Ollama runs as a Go binary, llama.cpp is C++, and cloud APIs require no local Python at all. Meanwhile, developers new to agent workflows are discovering the conceptual landscape. One user in the Ollama community described building a Python script that loops through source code, calling an internal Ollama instance for reviews, then wondered about having the LLM decide what context to include in prompts, essentially rediscovering the concept of agents without knowing the terminology. Community members pointed them toward frameworks like Pydantic AI with tool function calls and MCP servers, or self-hosted N8N for workflow automation. A more rigorous treatment of agent safety appears in a recent RxEve paper introducing the concept of proof-carrying AI agents for data lakehouses. The authors argue that API-first, programmable lakehouses provide the right abstractions for agentic workflows, demonstrating through a proof of concept how untrusted AI agents can safely repair data pipelines using correctness checks inspired by proof-carrying code. The paper focuses specifically on pipeline repair as a case study because pipelines cover a large portion of lakehouse workloads. Data engineers spend significant time fixing broken ones, and the task serves as a test for agent capabilities in high-stakes scenarios challenging even for expert humans. The key insight is that traditional systems resist automation due to heterogeneous interfaces and complex access patterns, while code provides a suitable interface for agents, cloud systems, and human supervisors. Working open-source code is available at the project's GitHub repository. Section LM model selection and benchmarking. Choosing the right model for a specific task remains one of the most time-consuming aspects of building LLM-powered systems. A new tool from NextToken attempts to automate this process entirely, providing a zero-setup agent that benchmarks multiple open and closed-source LLMs on custom problems and datasets. The workflow demonstrated on the tweet-eval emoji prediction task illustrates the approach. Users load or connect their dataset, explain the problem, and ask the agent to test different models. The agent curates an evaluation set, writes inference scripts calling OpenRouter in the example, kicks off background jobs, and reports key metrics. Users can then request analysis of predictions, benchmark additional models with automatic cost estimation, and visualize relative performance. The surprising result from the demonstration, Llama 370B outperforming GPT-4o and Claude 3.5 on this particular task, highlights why task-specific benchmarking matters more than generic leaderboard rankings. Speaking of leaderboards, Minimax released M2.1 with impressive claims about democratizing top-tier agentic capabilities. The model shows particular strength in multilingual scenarios, outperforming Claude Sonnet 4.5 on multi-bench, 49.4 versus 44.3, and SWOI bench multilingual, 72.5 vs 68.0. On the standard STUI bench verified benchmark, M2.1 achieves 74%, placing it behind Claude Opus 4.5, 80.9%, and GPT 5.2 with thinking, 80%, but ahead of DeepSeek v3.2, 73.1%. The model was evaluated across multiple coding agent frameworks to demonstrate framework generalization and stability, with consistent performance on specialized benchmarks, including test case generation, code performance optimization, code review, and instruction following. For practitioners with specific hardware constraints, the model selection calculus becomes more concrete. A user with a new RTX Pro 6000 seeking to process 300 million tokens with strong instruction following received practical guidance. Start with the GPT-OS models, use vLLM or SGLang, run as many parallel threads as space allows, and don't configure more context than actually needed. The 120B model should push through 300 mem tokens in less than a week on that GPU, while the 20B variant offers faster processing at reduced capability. The reasoning for starting with larger models applies broadly. Figure out the task with a capable model before using benchmarks to scale down, since if the large model can't work in your harness, the small one definitely won't. On the code assistance front, a developer seeking to replicate their ChatGPT-based workflow for patching software locally received recommendations spanning model choice, hardware, and workflow optimization. Their current approach, asking for search keywords, reviewing grep output, examining specific files, iterating through build errors, works well in the narrow scope of making small changes to existing codebases. One respondent suggested loading entire source code into RAG, using LM Studio's drag-and-drop functionality, potentially allowing the model to search documentation itself, rather than relying on manual keyword identification. RAG and context management systems. Standard RAG systems struggle with multi-hop reasoning, questions requiring information from multiple documents connected through intermediate concepts. A paper introducing SRAG applies spreading activation, a concept from cognitive psychology, to GraphRag-style retrieval to address this limitation. The approach treats retrieval as a structural graph problem rather than a prompting problem. Instead of relying on iterative LLM-guided query rewriting, activation propagates automatically through a knowledge graph starting from query-matched entities, surfacing bridge documents that standard RAG often misses. The technique works with small open-weight models without retraining and shows strong gains on multi-hop QA benchmarks, including Music and 2Wiki multi-hop QA. Community discussion noted this resembles existing GraphRag implementations that retrieve large chunks of the graph neighborhood around retrieved nodes. If the knowledge graph is decent, nearby nodes often provide useful additional context. Context management challenges extend beyond retrieval to understanding what's consuming precious tokens. Claude Code users face particular opacity about where the system pulls information from. There's /Claude/ with projects and plans .claude/ in project directories and claude.md files at various levels. MCP servers in particular waste significant context. One experienced user recommends removing them entirely in favor of Claude skills. For claude.md files which support nesting, the advice is to keep root-level files short and put specific information in subdirectory files. A more systematic approach to this problem comes from Claude Cognitive, an open-source tool providing working memory for Claude Code through persistent context and multi-instance coordination. The project addresses Claude Code's fundamental statelessness. Every new instance loses prior context, forgets architecture discussions, and rereads documentation from scratch. For large code bases exceeding 50,000 lines, this becomes increasingly problematic. The solution implements an attention-based context router with 3 tiers. Hot, score 0.8 for full file injection during active development, warm, 0.25, 0.8 for headers-only background awareness, and cold, 0.25 for files evicted from context. Files decay when not mentioned, attention score multiplied by 0.85 per turn, activate on keyword detection, and co-activate with related files. The example flow shows how mentioning orin boosts system's orin.md to score 1.0 while co-activating related files at plus 0.35, then gradually decaying over subsequent turns without mentions. A cross-instance coordination pool handles long-running sessions spanning days or weeks, auto-detecting completions and blockers to prevent duplicate work across instances. The project achieved 33,000 plus Reddit views and number 18 on Hacker News within 48 hours of launch, suggesting significant demand for such tooling. Developer tools and code processing. Feeding real website code to LLMs for interface replication or refactoring has been hampered by browser save page as functionality, which produces flattened HTML files rather than the separate JS, CSS, and asset files that make code understandable. PageSource addresses this by capturing all separate JavaScript files, CSS, images, and fonts in their original folder structure. The tool optimizes for inspection and understanding what LLMs need, rather than viewing what browser save provides. This makes it suitable for cloning websites or refactoring components into frameworks like React. Installation is straightforward via pip, and usage is a single command with the target URL. The distinction matters. LLMs benefit from seeing code organized the way developers actually work with it, not the flattened representation browsers generate for rendering purposes. PDF text extraction, a perennial challenge for document processing pipelines, receives attention from ZPDF, a library written in Zig that emphasizes high performance through memory map parsing with SIMD acceleration. The library supports multiple decompression filters: flat decode, ASCII 85, SE hex, LZW, run length, font encodings, WinANSI, MacRoman to Unicode CMAP, and XREF table and stream parsing for PDF 1.5+. Notably, it includes structure tree extraction for tagged PDFs, PDF UA, with fast stream order fallback for non-tagged documents. The former handles complex multi-column layouts correctly, while the latter works on any PDF but may not match visual order. Python bindings via CFI extend accessibility beyond Zig developers. For those working with vector databases, VectorDBZ offers a desktop GUI application for exploring, managing, and analyzing vector embeddings. The tool connects to multiple databases simultaneously, supports pagination through large datasets, and provides visualization of embeddings in reduced dimensions using PCA, TSNE, and UMAP algorithms. Analysis capabilities include dimensionality metrics, k-means and dbScan clustering with silhouette scores, anomaly detection, and near-duplicate identification. Custom embedding functions with templates for OpenAI, Cohere, Hugging Face, Ollama, and Gina AI allow text or file embedding generation directly within the application. Cross-platform support covers Windows, macOS, and Linux. Decentralized communication protocols. The BitChat protocol represents a serious engineering effort toward decentralized peer-to-peer messaging designed for scenarios where internet connectivity is unavailable or untrustworthy. Protests, natural disasters, remote areas. The white paper details a 4-layer protocol stack combining modern cryptographic foundations with flexible transport mechanisms. The design goals are explicit: confidentiality, communication unreadable to third parties, authenticity, identity verification, integrity, tamper-proof messages, forward secrecy, compromised long-term keys don't expose past sessions, deniability, difficulty proving specific users sent particular messages, and resilience, reliable function in lossy, low-bandwidth environments. The protocol stack separates the transport layer, Bluetooth Low Energy, Wi-Fi Direct, encryption layer using the noise protocol framework with the XX pattern for mutual authentication, session layer managing routing and fragmentation, and application layer defining message structures. Identity management relies on 2 persistent cryptographic key pairs generated on first launch: a noise static key pair for handshake identity, and a signing key pair for binding public keys to nicknames. A user's unique fingerprint is the SHA-256 hash of their noise static public key. An implementation extending these specifications appears in BitChat QDAG, which adds quantum-resistant cryptography and WebAssembly support. The library implements ML7N68, NIST approved, for key exchange, a hybrid mode combining quantum-resistant and traditional cryptography, and automatic key rotation with ephemeral key exchanges. Transport flexibility spans Bluetooth mesh with automatic message hopping, Internet P2P via libp2p integration, WebSocket, and local networks. Privacy features include a 12-hour message cache with configurable retention, no registration requirements, self-destructing messages, and adaptive dummy message generation to prevent traffic analysis. Related infrastructure includes EdgeNet, an NPM package in the ecosystem supporting these decentralized communication patterns. The tooling around these protocols continues to mature, though mainstream adoption remains limited. Section: Emerging AI Models and Capabilities. Image editing models receive a performance boost from Qwen Image Edit 2511 Lightning, a collection of optimized models using step distillation and quantization for high-efficiency inference. The repository hosts 3 variants: a 4-step distilled LoRa in BF16 precision, the same in FP32 for higher accuracy, and an FP8 quantized version fused with the 4-step distilled LoRa for low memory deployment. The key optimization is step distillation, reducing inference from the original 40 steps to just 4 steps, approximately 10x speedup while preserving image editing quality. FP8 quantization further reduces GPU memory usage by roughly 50% compared to FP32 while maintaining editing fidelity. The models integrate with both the Qwen Image Lightning ecosystem and the LightX2V lightweight video image generation inference framework. On the infrastructure side for training and inference, Fusco provides high-performance distributed data shuffling specifically for mixture of experts (MOE) architectures. Building on NCCL's network abstraction layer, the library supports diverse cluster networks including NVLink, PCIe, InfiniBand, RoCE, and TCP/IP. Benchmarks on 64 H100 GPUs across 8 servers show performance on the DeepSeek V3 MOE setup with 768 hidden dimensions and top 8 experts. The library addresses dispatch and combine operations under different routing scenarios, measuring total time for pre-MOE and post-MOE data permutation, alongside communication latency. Infrastructure and storage technologies. Grid-scale energy storage remains a critical challenge for renewable energy adoption, and a pilot project in Sardinia offers an unconventional solution: liquid carbon dioxide. The principle is straightforward. When excess power is available, CO2 is compressed, cooled, and liquefied into pressure vessels. When power is needed, compressed CO2 runs through a turbine. Since releasing CO2 defeats the purpose, the gas is stored in a large containment bag between cycles, described colorfully as like the world's heaviest and saddest dirigible. The Sardinia facility specifications are notable: 2,000 tons of CO2 capacity, 20 megawatts output, up to 10 hours of generation for 200 megawatt hours total, all on 5 hectares of land. The 10-hour duration exceeds typical grid-scale battery farms targeting 6 to 8 hours. Advantages over alternatives include scalability, requiring only additional land rather than specific topography, unlike pumped hydro, safety compared to battery chemistries that can catch fire, and no special geography requirements. Energy Dome, the company behind the project, plans installations in India and Wisconsin for 2026, with Google planning deployment at data centers worldwide. For AI-specific infrastructure, NornicDB offers a graph plus vector database built specifically for AI agents and knowledge systems. The database speaks Neo4j's protocols, Bolt and Cypher, and Qdrant's gRPC language, enabling zero-code change migrations while adding features including a GraphQL endpoint, air-gapped embeddings, and GPU-accelerated search. Docker images are available for Apple Silicon with Metal acceleration, NVIDIA GPUs with CUDA, Vulkan-based systems, and CPU-only deployments. The BGE M3 embedding model comes bundled in certain image variants, and a Heimdall UI option provides visualization capabilities. For those wanting to understand deep learning infrastructure from first principles, a new online book walks through building a deep learning library from scratch, starting with a blank file and NumPy, progressing through AutoGrad engine implementation and layer modules, culminating in training MNIST, a simple CNN, and a simple ResNet. The educational approach of building rather than merely using frameworks provides understanding that proves valuable when debugging or optimizing production systems.